You know that feeling, the sun on your skin on a long, hot summer day? It just feels like we have to be closer to the sun, doesn't it? Well, what if I told you that for most of us, it's the exact opposite? Today, we're going to bust one of the biggest and most common myths in all of science. So let's just ask it straight up. Why do we have seasons? What's the real reason we get scorching summers and freezing winters? Well, the answer is probably not what you're thinking. And honestly, the real reason is so much cooler. Our journey to that answer starts by tackling a very popular and very wrong idea. Okay, so here's the popular idea, the one we all kind of grew up with. It's summer because the Earth is closer to the sun. And it makes intuitive sense, right? You get closer to a campfire, you feel more heat. But the real science, well, it's way more elegant. It has almost nothing to do with how close we are and everything to do with a little lean. Now, to be fair, the whole closer to the sun thing isn't completely out of nowhere. The Earth's path around the sun isn't a perfect circle. It's actually a slight oval, which means our distance does change a bit throughout the year. But, and this is a big but, here's the part that just blows that whole theory right out of the water. Okay, you ready for this? This is the killer fact. In January, when the northern hemisphere is in the absolute dead of winter, we are actually closest to the sun. Yeah, you heard that right, closer. And in the middle of summer, we're millions of kilometers farther away. So if distance was the key, January would be beach season for half the planet. All right, so if it's not distance, what is it? To get the real answer, we need to quickly understand the two main ways our planet moves through space. You can think of them as Earth's two big cosmic dances. So our planet is basically a master multitasker. It's doing two things at once, all the time. First, it's spinning on its axis like a top. That's called rotation. And second, it's making a giant lap around the sun every year. And that's revolution. And these two dances have totally different results for us down here. Rotation is the simple one. It's our daily clock. That 24-hour spin is what gives us day and night. Easy enough, right? But revolution, that's our yearly calendar. That 365-day trip around the sun is the key to the seasons, but only when you combine it with one other critical ingredient. And this is it. This is the secret sauce. The real star of the show. Earth's tilt. See, it's not about how close we are. It's about how we're angled. Here's the magic number that changes everything. 23.5 degrees. Earth isn't spinning perfectly upright compared to its orbit. Nope. Its axis, that imaginary pole going right through the planet from top to bottom, is leaning over by 23.5 degrees. And this is maybe the most important part of the whole puzzle. As Earth makes its year-long trip around the sun, that tilt doesn't wobble around. It stays pointed at the exact same spot in space. It's locked in. And that one simple fact, that consistency, is what makes everything else happen. Okay, so why is a little tilt such a big deal? Well, it all comes down to how concentrated the sunlight is. Think about it with a flashlight. If you point it straight at a wall, you get a small, super bright, intense circle of light, right? But what happens if you angle that flashlight? The light beam spreads out, gets bigger, and a lot dimmer. Sunlight works exactly the same way. Direct, focused rays are powerful and warm. Angled, spread-out rays are weaker and cooler. So the tilt gives us a 1-2 punch. First, it changes the angle of the sunlight, which affects how intense it is. And second, it changes how long the sun is in the sky. So in summer, you're getting more direct, powerful sunlight, and you're getting it for more hours each day. In winter, it's the opposite, weaker angled sunlight for fewer hours. It's that combination that really drives the change in temperature. All right, let's put it all together. We've got the Earth making its yearly lap, that's the revolution, and we've got that constant, stubborn 23.5 degree tilt. So how do they actually work together to create the seasons? Let's take a little trip with the Earth for a full year and see it in action. As you follow Earth around its orbit, you can see it plain as day. Let's say it's June. The northern hemisphere is tilted towards the sun. It's just soaking up those direct rays. The days are long. Bam, that's summer. Now fast forward 6 months to December. Earth is on the other side of the sun. But remember, that tilt is still pointing the same way in space, which means the northern hemisphere is now tilted away from the sun. It gets weaker rays and shorter days, and that is winter. And this, of course, is exactly why the seasons are flipped in the northern and southern hemispheres. When the top half of the planet is leaning in for its summer, the bottom half is leaning away, stuck in winter. So yeah, while someone in the US is firing up the barbecue, someone in Argentina is probably looking for a warm coat. Now, this whole yearly cycle isn't just one smooth, gradual transition. It actually has 4 key milestones. 4 official turning points in our orbit that have special names that you've probably heard of: the solstices and the equinoxes. And the concept is really straightforward. Solstices are the extremes. That's when one hemisphere is tilted as far toward the sun as it can get, that kicks off summer, or as far away as it can get, that starts winter. The equinoxes are the 2 perfect in-between moments. That's when the tilt is perfectly sideways relative to the sun. Day and night are almost exactly equal everywhere, and that's what kicks off spring and autumn. And we can see exactly how this plays out for both halves of the world. Take the June solstice. For the north, it's the longest day of the year and the start of summer. For the south, it's the shortest day and the start of winter. Then the December solstice just flips that whole script. And the equinoxes in March and September, they're the great balancers, bringing spring and autumn to the entire planet at the same time. And this isn't just some abstract space fact. It literally shapes life on our planet. I mean, get a load of the Arctic tern. This little bird is a genius. It's basically hacked the system to live in an endless summer. It hangs out and breeds up in the Arctic during the northern summer. Then, as winter starts to creep in, it just flies, get this, 30,000 kilometers all the way down to Antarctica to catch their summer. It literally follows the Earth's tilt around the globe every single year. So there you have it. Let's put that old distance idea to bed for good. It's not about how close we are. The beautiful clockwork reason for our seasons is all because our planet is tilted. That simple 23.5-degree lean, combined with our yearly trip around the sun, creates the world we know and love. And that leaves us with one last thing to chew on. This tilt isn't just some minor detail. It has shaped everything, from our weather and the evolution of life to the very rhythm of our civilizations. So just imagine for a second, what would our world be like with no tilt? No seasons at all. Just one unchanging climate, day in and day out forever. It's a pretty different planet to think about.